Hello friends. So good evening to all of you. So today I am going to discuss about uh, like physical chemistry, and in this lecture I will give some basic information about hydrogen like atoms, all details like Bohr models of atom and their postulates, as well as the Bohr equations for energy of electron in hydrogen and hydrogen like atoms, and some questions. So basic things here you have to know what is the basic things. So Bohr's models of atoms. So Bohr's studies, and he proposed this model in 1913, and what he proposed, actually before these Bohr's models, one scientist give some information related these models. His name Rutherford. So before he start this model, he follow the Rutherford model, that the nucleus means fundamental statement he followed. What that fundamental statement? The nucleus is a positive charge present at the center of atom, having positive and protons as negative electrons. Okay, so here the Bohr agree of this statement, and they further move and follow these statements, and he said the actually the electrons revolving around the nucleus, and he applied the Planck quantum theory on revolving nucleus. So like see here, this is the nucleus, positive charge, and this electrons which is moving around the nucleus. This is negative charge and this is positive charge. So up to here this is the statements. Now we move to the postulates. What was the postulate? So postulate actually tells us fundamental things, like here they have included also the same things like electrons present in an atom which revolves around the nucleus only in a certain circular orbit, and it neither loss nor gain energies. Okay, so electron will not move in any different orbit, only electron will move in a certain circular orbits, and that it will not lose or gain any energy, means energy will, what I can say, means constant. And this idea further he leads in a orbit with associated deficient energy. this idea leads to the orbit having associated energies. Okay, so first postulate we understood. Okay, first postulate says the electron moving around the nucleus, and this electron only move in a certain circular orbit, not any other orbit. Okay, and it will not gain any energy or loss any energy, means energy will constant. Okay, now move to second statements. What second postulate? Energy of electron cannot change continuously, means energy of electron will not change continuously. Okay, means if you see here, if you see here some energy, and if you see here some energy, so it is not like that. And energy will continually same, and these things only possible when electrons means it is only possible when electron means here here the statement is little bit confusing, but not, I am telling you, energy will not change continuously, and this is possible when electron jumps from one energy level to another energy levels. So here here this sentence telling like this. So this, when this energy is changed, then this will things will happen, means electron jumps from one energy level to other energy level. So second statement says the energy of electrons will never change, it remain same continuously, and this will only happen when the electron jumps from one orbital to other orbitals. Okay, so second postulate also is clear. Now move to the third postulate. So third postulate says the angular momentum of an electrons moving around the nucleus, which is quantized. Okay, angular momentum of an moving electron around the nucleus is quantized, means momentum of this moving electron is fixed, not change. Okay, like see here, this is your nucleus and this is your electron which is moving in a certain circular orbit with velocity of v. Okay, and this is the distance from nucleus to electron. Okay, distance r. So here the angular momentum we can write here mv/r. m is the mass of electrons, is the velocity of moving electrons, and r is the distance between nucleus and electrons. Okay, so third statements, postulates, also clear. Okay, so where r is the radius of orbital, so also we can write this formula mvr is equal to n, where n is the any integer. Okay, n is the any integer like 1 2 3 4. Okay, and h upon 2 pi is the constant. Okay, right, so these are all clear. Okay, you can also read from books, these things are given in any books. Okay, now move to the Bohr equation for energy of electrons in hydrogen and hydrogen like atom. Means here we calculate the means derive the energy of electrons in nth orbital. Okay, and this energy we will here describe like for hydrogen and hydrogen like atom, not other atoms, like only a single electron. Those types of ligands where present only single electrons. Okay, so here the hydrogen and hydrogen like atoms such as helium plus, lithium 2 plus, and were having single electrons. So Bohr here assumed that electron remain its orbital. Here they follow this first postulate, okay, and assumed electron remain its orbit, okay, because of electrostatics force of attraction, and it will not jump from one orbit to any other orbit because due to electrostatic force of attraction, and this force balanced by centrifugal force, okay, which is arises from its circular motion. Okay, so here these things he has assumed electron remain in its orbit because of electrostatic force of attraction, and this force of attraction is balanced by centrifugal force which is arised due to the circular motions. Okay, right, so you can see here this is nucleus, this is your electrons, and this is moving in a circular orbit with due to the electrostatic force of attraction. Okay, so this force will balance by this this Z is a positive charge and electron is negative charge upon R square is equal to the mv square into R. Okay, so here we easily find the velocity. Okay, either we can write in this form also, v is equal to under root of Z a square upon m R. Okay, right, this is only manipulating, not big issue. Okay, this will this is remain, and you m and R you send this side, a little bit confusing, huh? With this thing will go this side, this, okay, sorry, so here is the 1 minute. Sorry, mv square upon R, sorry, this, so 1 R will cancel out, then 1 R will remain. Okay, so we will get V. Okay, so V square is equal to Z E square upon mr. Okay, so you will get V velocity. So this velocity, from this, with this velocity, electron is moving in a circular orbital. So, and also we can find the Bohr radius r1 is equal to a0 is denoted as a Bohr radius. H square is h square upon 4 pi square. This is 4 pi square m e minus. Okay. So now finally I am directly here putting the energy of nth orbital, but this will come step by step. You can, if you want to know how this equation has come, then you can go follow any books. There mention the derivation details in details. Okay. So because I am not interested to give detailed information, I am shortly given this equation, nth equation, energy equation of nth orbitals. Okay. So here we directly find the nth energy of this electrons, 2 pi s square z square m e k power 4 n square h square. So this nth energy proportional to the z square of n square. Okay, is proportional to z square upon n square. Okay, and you can also put minus. Okay, don't do minus because minus is also here, minus is given. So this equation is very very important. Several in exams this related this question, this formula, there are several question has been come. Okay, so I put it one question here. Calculate the ground state energy of the electrons in electron volts. Okay, in electron volts for hydrogen species, and here they have given a Rydberg constant RH, which is 13.6 electron volts, and so here we have to calculate the ground state energy. So you have to follow this formula. This is nth orbital, and here they have said in this question they are asking the ground state. Ground state means n is equal to 1. Okay, so simple. This is Rydberg constant, whole thing. This is the Rydberg constant, except these things, this term RS is the Rydberg constant, and they have in means derivation they have put some constant value, means 13.6 electron volts. Okay, right. So En is equal to minus RH z square upon n square. So simply you put z is equal for hydrogen atom, z is equal to 1, and ground state energy means n is equal to 1. Simply you will get this value 13.6, right? So this is the basic things you people read in like in lower classes, but just reminding things. Okay, just a reminding, not. But you have, if you reading physical chemistry, so you should know basic things of Bohr's models. Okay. So uh, now I am thinking to give some other extra point, some points. Some points means related means some Heisenberg uncertainty plus one wave particle duality means. So first erase this thing, then I will give. Right? Okay. So what is Heisenberg uncertainty principle? So this things also is very simple, but I am here reminding you only. So okay. So what is Bohr's uncertainty principles? So Bohr's uncertainty principles basically gives the information about the nature of the means lights as well as matters. So in this uncertainty principles, here we can't the determine simultaneous position as well as velocity, means momentum of any minute particles. Okay. So here Heisenberg uncertainty principle. So because video is going too much long, lengthy, so I am going short form and shortly information. Okay. So Heisenberg uncertainty, as we know, the we can't determine the simultaneous exact position as well moment, can't determine the position and momentum of any moving minute particle. Okay. Can't determine simultaneously. Okay. Can't determine simultaneously the position and momentum of any moving particles. Okay. So these things is very simple. And there are duality natures of wave particles of electrons. So here the Einstein suggested that the light has dual characters, wave as well as particles. So before going to the duality natures, I will give the formula. One formula is very important formula, this related uncertainty principle, like del x del pz lx del px greater than or equal to h upon 2 del x del p greater than or equal to h upon 4 pi. Okay, this is very important formula. And if you know the momentum of any minute particle, then you will calculate easily the position. Okay, if position is given, you can calculate momentum. If the given the velocity of any electrons, and then you know the mass of electron, you will get the easily velocity. Okay, so this formula is very important of this Heisenberg uncertainty principle. Okay, now quickly I will give the de Broglie equations. Okay, so de Broglie equation basically based on the wave particle duality natures. Okay, so here Bohr's theory said the electron is treated as a particles, but de Broglie theory suggested the matter, and therefore electron also has a dual character. So both material particles and as a wave. So he derived a expression which calculate the wavelength lambda of any particle with mass m moving with velocity. Okay, so lambda is equal to h upon mv. Lambda is equal to h upon mu. So this is the de Broglie equation. So, and as you know, the mu is equal to p, momentum, so you can write h upon p. Okay, so here you can also find the if the momentum is given, then you will calculate the wave length, and if wavelength given, then you will calculate the momentum. So okay, so in next video I will discuss next things. Okay, so up to here okay, enough, and 30-minute video is going. So okay, thank you, bye bye, and if you have any doubt, please comment, send comment, I will reply. Thank you, bye bye. And also I am requesting, please, if you are new in this channel, so please subscribe and like my channels. Okay, good night, bye bye.